Hey guys, in this video I want to show you a way to create a simple knitting effect in Houdini, so let's dive in. So first let's add a new geometry node. You can dive inside and here you can add a line. So here by default the line is going up on the y-axis, so you can press P on this node to open the parameter of the line. And in my case, I will add the line on my z-axis, so I can put 0 on the y-axis and put 1 on the z-axis. So here I can increase the length to 2. And now I can add a match size node to put this line at the center of the scenes. Now let's add a resample node to increase the resolution of the line. And in my case, I will disable these options and I will put a fixed segment number. And in my case, I will increase the segment number to 500, but you can always change this resolution at any time. So here I will also enable my curve view attributes. So now let's add an attribute remap, and we can remap the curve view attributes that we have created with the resample node. So to visualize the curve view attribute, you can select the resample node, you can click on the eye icon here, and you can visualize the curve view attributes. And you can see that we have an attribute over the line going from 0 to 1. And here with the attribute remap, we can use this curve view attribute to create a new attribute to control the noise with a mask. So here for the original name, we want to take our curve view attributes. And here for the new name, we can rename it something like mask noise. And here you can remap the attribute to something like this. So you can put a dot at the middle of the ramp. So you can put the position at 0.5 and you can put the value at 1. And here for the last one, you can put the value at 0. So here you can select these little options and you can put that to monotone cubic to get something a bit more smooth. So now we want to deform the line. So to do that, you can add an attribute noise. And here with the attribute noise, by default, the attribute is on CD, which is a color attribute. In our case, we want to deform the position of the line. So here you can type uppercase P. And in that case, it will create some noise on the line. So here we want to change the range value from positive to 0 centered. And here we want to enable the noise only on the X and Z axis. And we want to disable the noise on the Y axis. So here you can click on this little icon to disable the Y axis. Also, we want to multiply this noise with the mask noise attribute that we have created with the attribute remap. So to do that, you can select the attribute noise, you can click on blend, and here you can blend with an attribute. So instead of constant, you can put the mode to use attributes. And here you can replace the attribute with the attribute created before called mask noise. So here we can change some settings for the noise. In my case, I will put the amplitude to 1.43. I will put the element size to 3.19 and I will go to the fractal tab and I will decrease the roughness to something like 0.193. So now we want to create some thickness on this line for the knitting effect, but first let's define a normal directions. So let's add an attribute wrangles, and here to define the normal direction you can type @n in uppercase, which is a normal attribute, and here you can use the set function to define the vector directions. In my case, I will put the normal positive on the x-axis. So let's put 1 for x, 0 for y, and 0 for z. And now you can visualize the normal by clicking on these little icons. And you can see that the normal are going in positive directions on the x-axis. So now let's use the poly extrude node to create some thickness on this line. And here with the poly extrude, you can put the distance to something like 0.313. And here for the extrusion mode, you can change it from primitive to point normals. And here you can put the normal to existing. So now you have this kind of ribbons. Now let's add a match size node to put this geometry at the center of the scenes. Now let's add a fuse node. And let's keep everything by default. So now let's duplicate this geometry. So in my case, I will create 4 knitting shapes, but it's up to you. So let's add the copy and transform node. And here with the copy and transform node, I will put the total number to 4. And here I will change the translation on the x-axis to maybe 0.3 or something like this. So at the moment, I will put the value at 0.325, but later I can change this value if needed. Also, you can enable the copy number attribute. So here you can enable these little options. So in that case, you have an attribute for each individual copy. So now let's create a group for the outer edges. So here for the group, you can rename it something like out edges. And here you can change the group type from primitive to edges, and you can enable the options include by edges. And here you can click on unsure edges. So in that case, you have a group with the side edges here, and you can disable this. So now let's remove all primitive but keep all edges. So to do that, let's add an end node. And here with the end node, you can change the close U to unroll with new points. And now you can dissolve the side edges that we have on each border of the different ribbons. So to do that, we can use the group that we have created before, and you can use the dissolve node. And here with the dissolve node, you can select the group called out edges. So you can select the group right here. And now we have only those different lines. So now let's add an attribute delete. And here with the attribute delete, you can go to point attribute and you can delete the curve view attribute. So now let's add a new resample node.
Most Houdini tutorials show you tricks. Very few teach you how to build real, production-ready setups from scratch. Artilabs is a premium Houdini training platform for artists who want production-level results, used in motion design, simulations, and high-end product visuals. You get 45+ hours of advanced content, including 2 complete courses where you build high-end animations from start to finish, exactly like in real client work. Every lesson includes full Houdini project files, so you're never guessing. You follow the exact workflow step by step. The library keeps growing every month. And right now, annual access is discounted with an extra 20% off for a limited time. Click the link below. Start building Houdini work that actually attracts professional clients.
Because we want to resample each individual lines. And here for the resample node, I will put the length to something like 0.01. In that case, I have a bit more resolution for each individual line here. And I can also enable the curve view attribute because we will use this curve view attribute to deform our line on the 3D space. So now let's create a fall-off for the knitting effect. So to do that, let's use a mask from geometry. Let's plug the line on the first input and let's use a box as a shape for the fall-off. So here we can plug the box on the second input of the mask from geometry. So let's see the result of the mask. So you can go to this node, you can go to the information tab, and here you can enable the mask attribute. So here let's place the box correctly. So you can go to the top view by pressing space 2 with the mouse over the viewport. And here you can select the box and you can change the position of the box with the little gizmo icon here on the left. So here you can change the size of the box to something like this and something like this. And here you can change the position on the z-axis to something like this. So let's keep the box at this position for now. So later we can change and animate this value over time. So let's go back to the 3D view by pressing space 1. So now let's create the strands shape and strands deformations based on our mask and our fall-off attributes. So to do that, you can use a point VOP. So here you can rename it something like knit settings. And here you can dive inside. So the first step is to split these positions vector into 3 different floats. So to do that, let's use the vector to float node. So in that case, we can get access to the X, Y, and Z components of these vector positions. And in our case, we want to deform our strands on the Y axis. So here, let's use the float to vector. And you can keep the X axis at these original positions, and same for the Z axis. In our case, we want to make some change only on the Y axis. So here you can plug that back to positions. So now let's add a parameter. So in that case, we can control the Y positions. So you can rename it something like Y pose for the name and same for the label, Y pose. And here you can put the default value to 1. So here you can put that to the Y axis, and you can see that we have changed the Y positions of our strands. So here you can change the value if you want. So 0 is the default value and 1 puts the strands at 1 on the Y axis. So of course, in our case, we don't want to put all the strands at 1 on the Y axis. We want to use our curve view attributes to create a nice shape for the strands. So to do that, let's use a bind to import the curve view attribute into the VOPs. So here you can change the name to curve view. And here the type is float because the value is going from 0 to 1 for the curve view attribute. And here to remap this attribute, you can use the ramp parameter. In that case, you can define a nice shape for the strands. And here for the ramp, you can change it to spline ramp. So now you can use a multiply node to multiply this Y position with this curve view attribute. So you can plug this one to the first input of the multiply, and you can plug that to the second input. So now let's add an add node, and you can add the original position of the Y axis to the first input. And you can put the result of this one to the second input of the add, and you can plug that to the Y components. So now you can go back to the SOP by clicking on these little Geo1 icons. And here you can define a ramp for the shape of the strands. And for now, let's put the value to something like this. So you can put the position to 0.5. And here you can select this and put monotone cubic. So here with the ramp, you can define a shape for your strands. So at the moment, let's keep it like this, and later we can make some change. And by default, the Y position is quite high. So for example, you can put the value at 0.25. And in that case, we have this result. So maybe you can hide the curve view attribute by disable these little icons. And now we have those strands. So you can make it visible or disable. It's up to you. So in our case, we want to deform our spline based on the mask attributes that we have created with the mask from geometry here. So we want to use this fall off to deform our strands. So you can go back to the attribute VOP, and here you can multiply this product with the mask attribute. So let's add a new bind. So here with the bind, you can import the mask attribute created in SOPs. So this is a float value because the value is going from 0 to 1. And now let's add a multiply node. So you can multiply this product with the mask attribute. So you can plug that here. And of course, you can remap the mask attribute with a new ramp parameter. So here for the ramp, you can call it something like ramp mask. And here you can put that to spline ramp, and you can plug that to the second input of the multiply. And then you can plug this product to this second input of the add. So in that case, we can multiply our deformation with our mask. So now you can go back in the SOP level, and here you can define a ramp for the mask. So for example, you can put the ramp to something like this, and here you can make this one a bit up. So in that case, you can keep some thickness on our strands. Maybe this one is a bit too high, so you can put it here, and you can decrease this one just a bit. And you can select these little options, and you can put that to monotone cubic. So for now we have this. You can go to the box, and here you can change the position on the Z-axis. And you can see that we can animate those knitting with the different ramps for the mask and also for the shape of the strands. So at the moment, all the strands will be deformed with the values that we've put here on the Y positions. So let's say that we want to create some random value for each individual strands. So to do that, we can use a prim number value. So let's put the Y pos to something like here. And let's add a new multiply node. So you can put the Y position to the first input of this multiply node. And here you can put the product of these to the first input of this multiply 1. So now let's add the random value to the second input of this multiply. In that case, we can create a random value for these Y positions. So let's take the prim number value and let's add a random node. So it will create a random value between 0 and 1. So here let's add a fit node. So in that case, we can define the random values that we want. So in the input, we have 0 and 1, and we can promote the destination min and destination max. So here you can click on the little gear icon, and you can promote this one, and you can also promote this one. So in that case, we can control the value in SOP level. So now let's add a ramp, just to get a little bit more control on the random value here for the strands. And here we can put that to the second input. And here for the ramp, you can rename it something like ramp round. And here you can put the type to spline ramp. And in that case, you can control the random value. So here you can go back to the SOP, and you can define a ramp for this random value. So at the moment, let's take the last point of this ramp, and let's put the value at 1. So at the moment, we have a random value from 0 to 1. So I think it's a bit too much. So we don't want to get some random value at 0. So of course, you can control the minimum and the maximum value for the randomness. So here maybe for the minimum value, I will put the value at something like maybe 0.85. So basically, if I put my minimum to 1, I don't have any randomness on the strands. So if I start to decrease this value, I will start to add some randomness. So let's put the value at 0.85. So now let's add a seed parameter to change the position of the random value. So let's go back to the attribute VOP. And to do that, you can add a new parameter. And here for this parameter, you can rename it seed, and same for the label. And let's put the default value to 1. And here let's add a multiply node. So you can multiply the primitive number with this parameter value. So let's plug the prim number to the first input of the multiply, and let's plug this parameter to the second input, and let's plug that to the random value. So here for this parameter, you can change it to maybe integer, and you can put the range to from 0 to 100. And let's put the default value to 10. So now you can go back to the SOP to define the shape and the deformation scale that you want. So you can click on that, and here you can define the shape for the strands. So in my case, I will select this little icon, and I will put my curve to B-spline. So here, let's take this one. Let's put the value at 1, and let's put the position to something like 0.1. So let's add a new point. So let's put the value at 1, and let's put the position to 0.9. And in that case, I have this kind of shape. So of course, you can tweak the shape if you want with the different point here on the ramp. But in my case, I will keep the position here at 0.1. So here, if you want, you can play with the seed just to change the position of the random value. So at the moment, everything is perfectly straight and aligned. So you can see every strand is perfectly aligned on the x-axis. So we want to add a bit of deformation to do strands to get something a bit more organic. So to do that, let's add a new point VOP. And you can plug that to the first input. So for this one, you can rename it something like noise settings. So you can dive inside. And here we can add a bit of noise to the original positions. So to do that, let's add an add node. Let's plug the position to the first input. And let's add the turbulent noise So you can plug the positions to the position input of the noise, and you can plug that to the second input of the add, and you can plug that to the output positions. So here for the noise, you can change the type to 3D noise, and you can put that to 0 centered per noise. So here, if you want, you can promote all those parameters to control the noise in SOPs. But first, let's add a random value for the offset based on each primitive number. So let's take the prim num. Let's add a random. So it will create a random value between 0 and 1. So let's add a fit range. So in that case, we can remap the value. So let's add the fit range. And here, like before, we can promote the destination min and destination max. So to do that, you can click on the gear icons, click promote parameter, and same for this one. And you can plug that to the offset of the noise. So in that case, we have something very random for each individual strands. And now you can promote everything else of the noise in SOPs. So to do that, you can select the node, right click, and you can go to Vex VOPs options, and you can click on create input parameters. So of course, we want to control the noise based on our curveview attribute. So to do that, let's add a bind node. Let's import the curveview attribute in VOPs. So let's replace the attribute name with bind. And this is a float attribute because the value is going from 0 to 1. So now let's add a ramp parameter. So here for the ramp, you can change it to spline ramp. And here you can add a multiply node. So in that case, you can multiply the noise with this 0 and 1 value. So let's plug the noise on the first input, and let's plug that to the second input of the multiply. So let's plug that to the second input of the add. And now let's add the parameter. So in that case, you can control the global amplitude for the noise. So you can plug that to the last input of the multiply, and you can rename it something like noise amp, and same for the label, noise amplitude. So here you can put the default value to 1. So now you can go back to the SOPs to create the ramp for the noise. So here by default, you can put the first point here at 0. You can put the second point, so let's say 0.15, put the value at 1, and here put the value at 0.85. And here you can select this, and you can put that to monotone cubic. So I have an issue here because on the bind node, I type bind instead of curveview. So of course you have to type curveview attribute here and not bind attribute. So in that case, you can control the noise based on the 0 and 1 value for each individual lines. So now you can make some settings here on SOPs, and by default, the noise amplitude is very high. So maybe in my case, I will put the value at 0.1 just to add a little bit of noise for each individual strands. So for the noise settings, I will increase the frequency to 3. Of course, it's up to you. And I will decrease the roughness just a bit, so I will put the value at 0.3. And if you want, you can tweak the minimum and maximum value here just to tweak some settings. So now let's remove some lines to create this reveal effect. So let's add a primitive wrangle. And here with these primitive wrangles, you can type something like if at mask is below, and here you can create a channel float. In that case, you can control the value very easily. So let's type CHF, and here you can type mask val, and here you can define our functions. So let's use the remove prim, and here you can type 0 for the first input. You can type at prim num for every primitive, and you can type 1 to delete the points. And here don't forget to close the curly bracket at the end. So now you can create this channel float by clicking on these little icons. So of course, our mask attribute is a point attribute, so I need to change the run over. It's not over primitive, but over points. So here you can change the value just to delete some primitive. So of course, it's up to you. You can make the value as you want, but in my case, I will put the value at something like, probably something like this. So now you can add an orient along curve, and here you can add a sweep node. And here with the sweep node, you can keep that to round tube, and you can put that to columned. So in that case, you can create more line based off each individual strands, and you can decrease the radius to something like 0.01. And here you can put the roll to something like 180, just to add a bit of roll to our sweep, or maybe 360. So it's up to you. So now if you want, you can change the global resolutions of the knitting effect by controlling the resample node here on the baseline. So in my case, I've put the value at 500, but if I want to decrease the resolution, I can put the value at 250, and now I have less strands. And if I want to increase the strands number, I can put that to 1000, and now I have way more resolution. So let's put the value back at 500. And here you can also play with the radius on the mask from geometry. So let's put the value at 1.25, and now I have something a bit more smooth. So here you can animate the box over time. So let's select the box. And let's animate it on the Z-axis to something like this. So let's put the value here on the Z and also here for the center. So let's go to the frame 120, and let's change the positions over time to something like here. And let's add a keyframe, and let's add a keyframe to this one. So let's select the box. You can go to the animation editor, press H, and you can select this and put that to linear. So now you have this knitting effect and you can control pretty much everything with the knit settings and the noise setting here. So now if you want, you can add a grid. And here for the grid, let's keep the value at 10 and 10. And let's put the rows and column to 250. So here let's add a mountain node. And here with the mountain node, you can play with some settings. So let's decrease the roughness to something like this. And let's increase the element size to something like here. And let's change the offset just a bit. So now let's add a point deform node. So here you can deform these strands based on the grid. So you can put that in the first input. Let's put that to the second input and let's put that to the third input. So in that case, you can deform the strands based on the mountain. And if you want, you can also use the copy num attribute for the shading. So let's add an attribute promote. And here you can promote the attribute from primitive to points. So let's select the copy num. And here let's add a color node. And here for the color, you can put that to ramp from attributes. And here let's select the copy num. So here let's put the range from 0 to 1 to 0 to 3 because our copy num attribute is going from 0 to 3 in my case. And here for the color, you can change it to something like infrared. And here you can disable this. And now we have set the color based on the copy num attribute. And here you can define the ramp to change the color of the different strands. So now let's add a null to specify this is the output for the knit, and you can rename it out knit. So that's it for today, guys. I hope you enjoyed it. You can download the final project file with the link in the descriptions. I'll see you in the next one. Bye-bye. That's it for today, guys. You can check out our website to get some premium courses, tutorials, project file, Houdini tools, and more. So check it out with the link in the descriptions.